Jim and Jenny Marshall. And I got 3 or 4 Xerox copies of articles that appeared in the Chemical Society and Chemical Engineering Society press just after last year's symposium. People independently saying, we ought to get these guys to talk to us about the rediscovery of the elements. Jim is a trained organic chemist with a bachelor's from Indiana University and a PhD from Ohio State. Jenny is an educator was trained as an educator in music and computer science with a Bachelor of Science and a Master of Education from Texas Women's University. Jim has spent his career at the University of North Texas and since 1967 has been involved in nuclear magnetic resonance, material science, chemical education, and the history of science. Jenny has been involved in the Denton Public School System up to 2003, teaching computer science and photography. Jim's research has resulted in over 100 publications, including a reference book on chemical analysis and several books on the history of chemistry and laboratory chemistry. Dr. Marshall co-founded the North Texas section of the Materials Research Society in 1983 and has held various positions, including president, for several terms. He's also served as the chairman of the Dallas-Fort Worth section of the American Chemical Society and for a decade has been on the American Chemical Society National Speaker Tour Circuit. Jim and Jenny married in 1998 and ever since have been a team to pursue their rediscovery of the chemical elements, a project to find all of the original sites of discovery for all of the elements. This investigation has taken them to many places, both in the old world and new world, including laboratories, universities, old homes, museums, mines, and other places of geological interest. Presently, they live in Denton, Texas, where Jim teaches at the University of North Texas, and Jenny pursues her own business in computer science. Now, at dinner, I found out that actually they can't stand the climate in Texas during the summer, and this is their official way of being in England and other cool places during that period. So our speakers are not only fully obsessed about what they're doing, they're also very bright. Please welcome at the computer, Jenny, and at the podium, Jim Marshall.
Is it on the right program? Is that the right program?
Yeah, it's ready.
All right, go for it. Put the volume up.
Yeah, I think it's
It is?
yeah.
whirlwind. It's our experience that instead of going slowly in each slide so that you can study it, people like to go fast, like we're walking, like we're really flying, like we're going through the fast trips that we usually take. So here we go. You get on your flying shoes, and we're going to give you just a sampling of the kind of trips that we take and the experiences that we have. Next slide. We married, as you were told, about 6 years ago. Is that correct? Okay. Her son and my son were roommates, and they introduced us to each other. And she said, go ahead. And she said, what shall we do? And I said, well, I've always wanted to go to Europe and find where the original elements were discovered. We can do that this summer. Right. And it's been many, many trips since then, and we're going to give you just a sampling of that. Next slide. And so, the New World discoveries are here, and there are a few of them. But, as you will know, there are more in Europe. So if we go to the next slide, we'll see we're going through the periodic table. There's going to be a quiz on this afterward. And we've been to every one of these places except two, and we have that covered by friends who have relatives at those two sites. They're in Russia. There's actually another one down there in Iran, Zinc. That's where Marco Polo went through. We haven't been there either. Maybe we'll go there someday. You notice that some elements appear more than once, and that's because the ore was taken from a mine, it was analyzed here, it was discovered here, the element, the metal was isolated, was reduced here, etc., etc. We're still going through the periodic table. We stop at uranium. The reason we stop at uranium is that we go beyond that, then we have the problem, how far beyond that are we going to go? And we do have a license to collect, next slide, we do have a license to collect elements beyond that. But we found out that if we do store californium, berkelium, etc., we have to put it in a drawer. We can never display it. And if we're going to take it out of town, we have to get a permit with the DOT, the Department of Transportation. So we just stopped at uranium. You've seen this slide before. One example, for example, strontium. What do we find out when we explore strontium? In the next slide, you'll find, well, it all starts. Here are some Scottish sheep as we go up the road to Strontian. And we were advised that in the Gaelic language, this means a lake across which the barges go. We take their word for it. Next slide. This is a one-lane road. I'm showing this particular for you, the mine in this particular region. There's some famous mines that you can buy minerals from. And you know, my ordinary crowd are chemists who know nothing about mines. You know everything about mines, so I can go a little bit more rapidly through slides such as this, even though they're dear to your heart. Next slide. Some of them are open like this. Finding the vein, finding the vein here, and then you can find samples in this particular mine in Strontia. Next slide. This is a lead mine. When you find the heavy earth carbonates, the barium and the strontium carbonates. I was asked at lunch, at dinner tonight, where strontium was discovered. There was a controversy between celestine and celestite. And actually strontium was discovered in the strontium carbonate, the strontianite from this particular mine. You can find clumps of lead there as well, galena, all over the place. Next slide. What happened is here in historic Southwark, which is the Charles Dickens territory, some of his really tawdry stories have a setting in this particular region. There was a St. Thomas Hospital here, which was a mercy hospital, a charity hospital. And at this particular hospital, next slide, which one wall remains, that's right here, because they cleared this area here for the railroad, which came through much later. In this hospital, there was a fellow where St. Adair Crawford administered ponderous spars, which at that time were any carbonates which are heavier than calcium, which meant strontium and barium. And he administered this to a number of the patients there. And since this was a charity hospital, a lot of them had venereal diseases. And he found out that there was a difference between the ponderous spars he was used to, barium salts, to some which were mined in Strontia. So, next slide, his helper were William Cruikshank, who incidentally was instrumental in developing some of the thermal theories later on. This is where we actually did the analysis here. If we go into the doorway right here, let's do that, Jenny. Here, in this particular laboratory, which they're refurbishing right here, probably the analysis was done, and that's where the element strontium carbonate was characterized. And next slide. If you go up to Edinburgh, I told you we were going to go fast, at the old university here, inside where the chemistry was done at that particular time, Thomas Charles Hope, his portrait's in a museum which is just up the street here. Sorry, we don't have enough time to take you up to that museum. But if you go to the new campus in Edinburgh, next slide, then you find in the museum there's this globe here. This is not Charles Hope. This is a fellow comrade here, a colleague, who then carefully put it on the table. Next slide. And you find out this is the 200-year-old strontium hydroxide, which was isolated and from which the material was characterized. These are the kind of stories that we find as we go along. It takes a lot of digging. But we have three things going for us now which we would not have 20, 30 years ago. One, we have the internet, so that we can transmit messages back and forth very quickly and get responses 5% of the time in a matter of days as opposed to months. It makes all the difference in the world. We've got GPS now. We carefully record each one of these sites. And third, the Iron Curtain is gone. Next slide. This is not behind the Iron Curtain. Here's another sample, an old sample prepared by Bunsen, University of Heidelberg, and this is in the new campus, cesium. This is elemental cesium in here, and it's in a display area. Next slide. This is with other exhibits he has around here. Next slide. Down this hallway, you have some of the old universities in Europe are so mindful of their history that they have these huge displays. It's just wonderful going through some of these places. This is in the Hörsaal, which translates to a lecture hall, I believe. The next slide, this is the outside, this is the spectroscope which he actually used to analyze, because you see he discovered rubidium and cesium by the spectroscopy of salts, which he obtained from a mineral spa which was nearby. Next slide, here's the original Bunsen burners. And when I asked my students in my own introductory class, what does Bunsen do? What did he do? Well, he invented the Bunsen burner. They know that. But then I asked him, what did he invent it for? He invented the Bunsen burner because it had a blue flame so that we could analyze the spectroscopy of their serious salts, which he was analyzing. Next slide. Here's the outside of the Hörsaal. I told you I was going to go fast, but we're just walking around. We're moseying around, seeing all these things. Now, next slide. If you go to Bad Dürkheim, and this is the source of the mineral water which the cesium was discovered. And these racks here, on the next slide, you'll see that they have bales of twigs here, which they would pile up, and the water would percolate down here and steam, and people will go inside here and get their steam baths. And he analyzed the mineral waters here and discovered cesium and rubidium from these particular mineral waters as the salt. Next slide. All right, if we go to the Altstadt, to the old laboratory where he actually did the analysis, it was right in here, and we just love plaques. We read this plaque, we read this plaque. This isn't a plaque, but it's important too. It advertises beer. And then we have another plaque down here, and we read all these plaques. Next slide. And here is a plaque that will make the back of the hairs in your necks just rise on in. See if I translate this. The gentleman from Berlin, tell me if I translated this correctly. In this house, Kirchhoff, in 1859, with the spectral analysis which he founded with Bunsen, from the sun and from the stars is able now to unlock the mysteries of the cosmos. Is that close enough? And was that the understatement of the century? Here's where he did it. Oh. And so we just sit there, we drink our beer, and soak in the German science. Next slide. Right across the street, you have the statue of Bunsen here. This is 52 Hauptstrasse in the Altstadt of Heidelberg. And we always go for statues, always go for statues. You want to go for some more statues? Let's have some more statues. Next slide, let's go. Well, here's one in Humboldt, Mexico City. We visited Mexico City 200 years to the date, to the arrival time that Humboldt, who made a tour, and he got a sample of La Vanadinita, it's Plomo Pardo, which is a grayish-brown lead, from which Del Rio had discovered vanadium. And that's a long story, too. Up here it says, to the Mexican folk from the Deutsche Kaiser, and this little inscription right here. Sorry, we don't have time to go visit those mines. Next talk, maybe we'll talk about that. Let's move on to another statue. Here's a Scheele in Stockholm. We just did a paper on him. He didn't do much, just discovered chlorine, oxygen, barium, molybdenum, and tungsten, HF, hydrogen cyanide, citric acid, tartaric acid, lactic acid, so on and so on and so on. And back then, the days that he lived, a chemist would naturally characterize a sample by smelling it and tasting it. And you can see he did not live very long. He lived 44 years old. And probably because he had inhaled so much chlorine and hydrogen cyanide, and believe it or not, H2S is more poisonous than either one of those in the same concentration. Pardon? And HF's bad too. Oh yeah. Anyway, marvelous fellow. I wish I had time to talk about him. Got to go on. Let's take up another statue. This is Berzelius, Stockholm. I read in a mineral journal 10 years ago, it says wherever Berzelius was, important things happened. Wherever there were important things happening, that's where Berzelius was. Just a giant of a person. He didn't do much. Discovered selenium, thorium, cerium, isolated silicon, zirconium. His student, Arvidsson, discovered lithium. I don't think we included the picture where Jenny was in a boat. We went to Norway where a scientist, mineralogist, took us to a boat and actually showed us the place where thorium was discovered, where an old parson was shooting ducks for his meals for his family, and I found the mineral which he sent to Berzelius to investigate. Next slide. And here's further out from Berzelius. This particular day we had to see the pigeon was sitting on his head and put a splatch all over it, so we had to wait till it rained to come back to take the picture again. He worked, that beautiful park. This is in the Berzelius Park in Stockholm. If you go where he actually did his work, next slide, you'll see, out of order, this is the following mine you saw before where he actually got the selenium to the ore which had the selenium in it, but he did the work in Gripsholm, a place which is miles away from there. Don't have time to go there. See the symbol up there? Alchemy. That's alchemy for Venus or copper. Next slide. Okay, here's where he did his work. This is in the German Baker House in Stockholm, he called it, where he performed all the famous work. You cannot believe, in the kitchen, a small room in here, he did the most fantastic analytical work, determining the atomic weights of elements to 5 places in some cases. From his work, from his analytical work, the very precise atomic weights were determined, from which the periodic table later was determined. Fantastic person. So, let's go visit this place. Go back a minute, Jenny. Go back a minute. Do you see these little eaves right here? These little eaves look so Germanic. That's why they call the German Baker House, I'm sure, because these are called the eyes of the house. We see this a lot in Germany. Next slide. Die Augen. Now, here's what it looks like now. It's a little shopping center here. It's gone. This is what you frequently find when you go back to the same spot. But that's all right. We just sit across the street and drink a Swedish beer in this particular case, soaking in all the Swedish science. Next slide. Here's the Berzelius Museum in Stockholm, and they are now moving that to the observatory. This fellow right here is Carl Grandin, who belongs to the Academy. And next slide, if you look across the way, if you go inside here, you'll see the museum. This is the old reflux condenser. Now, the chemists go nuts over this, because they say, oh my Lord, there's a cork bore in here and a cork here, and then you bore a hole and you put the little glass tubes in here. And here now you just buy one. They're so spoiled nowadays, aren't they? He made his own equipment. Here's this bath right here and so on. Next slide. We look across and we see here's the Swedish Academy here. On the next slide. The Swedish Royal Science Academy. We work real hard in trying to learn Swedish. Boy, it's a tough language. The Vetenskapen is almost like Wissenschaft in German, so you can see there's a little bit of resemblance in the language there. And inside here, we were taken where they cast the votes for the Nobel Prizes. We've had a fine time in here. Next slide. All right, so let's go to the place where they discovered lithium, which is a little island called Uto. Now, if anybody's from Sweden, you're free to correct my pronunciation. I've done my best to pronounce these the way they do there. You can tell what time we took off here, and we're going to get in the boat here. We're going to go to Uto, which is a little island where the lithium was procured. The lithium ore was procured. Next slide. Here we go. Dun, 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 dun. Isn't this beautiful? Next slide. Images like this. Here's a Swedish flag. See the blue and the yellow? Next slide. And so you go to the Uto guest home, which means the Uto guest harbor. I think ham is harbor in Swedish. And we get off and we go up. Here's the Gruvon, which this little symbol here means the scenic spot or historic site or important site. It's 0.5 kilometer up here, so we go up the hill. They have more windmills here than they do in Holland. We felt gypped when we went to Holland. Next slide. And beautiful scenes like it, just so majestic and beautiful. And we turn right around and we see here's the mine, Uto mine, and here's a little museum here. Next slide. We see nice little exhibits in here. Told you we're going to go fast. Next slide. Here's the sample here, which is from the area itself, the spodumene and the pedalite, which had the lithium in it. Now, thanks be to people like Tony Nikosher, we can get samples from the original mine because you can't get them anymore. They have to come from classic collections, and so people such as Tony have really helped us in collecting samples from the from old collections from the original site. And we worked real hard to get minerals from each of the original sites from which these elements were procured. But they had a sample like this in the mine itself, not in the museum itself, not for sale. Next slide. And so we go to, here's what the mines typically look like now. They're watered down, you can't go wandering through them, but this is where the lithium ore was procured. It's an iron mine now. It's an iron mine. And the next slide, some signs were in English. Oh, thank goodness. And so we could read through here and find out it's probably being mined in the 12th century and the Russians raided in the beginning of the 1700s. And you get the feeling things over there were old. Every grain of sand has passed through a number of hands, just countless generations of people and hands. Everything is old. Next slide. And then returning home. You know, scenes like this, they tell us because of the geologic isostasy, the land is rising 5 millimeters per year there. That's because the ice is melting and that land is actually coming up. We found that fascinating. There's a place in Finland we went to once where they actually marked the areas 500 BC, 500 AD, 500 BC, 2000 BC, where the sea level was at various, and the further up you go, the older it was because the land is rising. We find that fascinating. Next slide. Okay. All right, let's go to another region that has risen recently. Monte Palermo, which you will read in the old literature 500 years ago, 3 French leagues from Bologna. There's Bologna in the distance there. If you go wandering down to Bologna, you'll find the areas where Agricola and other famous people studied for their medical degrees 500 years ago. Oh. And we were told by an Italian geologist, please forgive me if there are any Italian people out there, what I'm about to say, but this Italian geologist, who was from Italy himself, said all Italy is just a great big old gravel pit that's been pushed up by the African plate mushing up, and all you get is just all the junk which has been lifted up. Well, in this junk you find lots of interesting things. In these wastelands here in the Monte Palermo, next slide, you'll find, here we are. It never rains in Italy, right? Yeah. Well, nuggets of Fosforo di Bologna, which are barium sulfate, barite. And next slide, you'll find out what this actually looks like in the museum here. It looks like an ammonite, doesn't it? And it's interesting. But that's what the barite looks like there. And these were the Fosforo di Bologna, which what they do is heat it and prepare it in a certain way, then it will glow in the dark. They call anything that glowed in the dark Fosforo, or phosphorus back in those days. And this was one of the particular minerals that glowed in the dark. So this is where barium was discovered. But then recognized as an element by Scheele. Remember the previous slide I showed you before? So these histories all intertwine, don't they? Just like a spider web. Next slide. Okay, speaking of museum specimens. Okay, let's go to some museums. Here's the Freiburg Museum. Now, I show this to my chemist audiences who don't have any idea of what seeing beautiful mineralogical specimens is like, and you know about all this. But I include this here to show you that I show them the same cinnabar from Almaden, Spain. Let's go on. This, I'm sure some of you have been here, haven't you? This is the Bergakademie Freiberg Institut für Mineralogie and the Geowissenschaftlichen Sammlungen for the exhibits there. Next slide. You have, this is a Roman mine we went into in Roșia Montană, Romania. Enough room for one slave laborer. This is fascinating. Next slide. Here is with the kind of labels you find for this. Hit it, Jenny. Native quicksilver, and the chemists are fascinated to find out, what? You mean quicksilver is just nature like that? Well, quick, get rid of it. It's poisonous, you know. And I've purchased various samples of native quicksilver, and I was told by Josef Vidak, some of you might know, how to tell real native quicksilver from fake quicksilver, which I didn't know. So here I show you, just hit it. Boom, he hit it. If all the mercury sprinkles off, to see that was fake. Somebody just sprinkled the quicksilver. Thank you, you just ruined my sample, but it was a fake. But then he sold me one, of course, which was authentic, and sure enough, you hit it and it adheres. And I did not know that. I did not know that. Next slide. Okay, here's the entrance to the Mineral Museum itself. And next slide, you'll see here is the famous mineralogist and director. This is Werner, who had the Neptunian hypothesis, which was that everything was laid down by water. Now, one of the people who had studied at Freiberg University, Humboldt, went to Mexico and saw so many volcanoes. He came up with the Plutonian theory of formation of minerals, that everything was created by volcanoes. The real answer? Well, it's both, of course, we know today. Next slide. Now, let's talk about Klaproth. This fellow right here discovered uranium. Let's take you on a little trip for this particular fellow. Next slide. I got this old painting here of the Rose Pharmacy of Spandauer Strasse. Am I pronouncing that right? Okay, all right. Where Klaproth discovered uranium across the street from the Holy Ghost Church. Isn't that the Heilige Geistkirche? Okay. And we needed to go find this place, because we wanted to find out where Klaproth had made all these marvelous discoveries. Okay, to make a long story short, next slide. Here is an old picture we finally got from the Catholic Archives in Berlin. And here's the Heilige Geistkirche, and here's the Apotheker right here. Ah, here's the apothecary, you know. Okay, now Jenny, we're going to go back and forth. Hit the next slide. All right, are we at the same place? Well, let's see. This is today. This is our picture. Go backwards. See this here? Go backwards. See, there it is right there. Go forwards. Okay. This right here. Go backwards. There it is right there. Yeah, okay. Now, very frequently they change steeples and other parts of a building, but this is the place, and so all we have to do is turn around. Jenny, let's go next. All we need to do is turn around and we'll see the apothecary. Are you ready? Are you ready? Hit it, Jenny. It's a bookstore. Right. Okay. Things change. But we sit there and have a drink in the German science with our German beer, and this is where it was. This is frequently what we find. Things have changed so much. Okay, next slide. Well, Tony Nikischer, we have to thank for this. We needed a contact to find out where the minerals were. He said, I know this fellow at the Natural History Museum in Berlin, in Wilhelmstrasse. So we went here. Okay, let's go in, and we made the contact. And they have an exhibit in Klaproth here. He didn't do much. Discovered zirconium, uranium, cerium, confirmed tellurium, titanium, strontium, chromium. He was a nice fellow. Most mineralogists are nice fellows, I found out, because even though he was a person who really confirmed the discovery and could have claimed discovery of these elements, he allowed other people to take the credit. Just a fine ethical gentleman. Next slide. And this is not Klaproth. This is Schmidt. And he has in his hand here, he's gone to the archives and brought them. Tony, I don't think you've seen these before, have you? And so let's find out what he has here. Here is the Torbenite, Klaproth Torbenite, where he originally discovered the uranium. Now, when we go back to the original source, Jenny and I, we frequently find there's a lot of errors in the literature because there's a lot of redaction. And the wrong fact then gets redacted, redacted. When we went back to the original work here, we find out that even though the literature says that Klaproth discovered the uranium from pitchblende, uranium oxide, UO2, he didn't. He discovered from torbanite. And here's the sample right here. There's a label here. Next slide. Let's see what it says. It says Grüne Uranglimmer, Georg Wagsfort, Johann Jorgenstadt. Now in German, glimmer means mica, if I'm correct. So uranium, mica, green uranium, mica is torbanite. At the Georg Wagsfort mine in Johann Jorgenstadt. So we got to go, don't we? Let's go. All right, let's go. Here we go. Oh, isn't that beautiful? Oh, just beautiful countryside. We're renting a car for this. We're approaching the Erzgebirge, which is the Ore Mountains. That's the boundary between Czechoslovakia. I keep saying Czechoslovakia, it's Czech Republic now, and Germany. Next slide. Going up. Next slide. Here's Johann Jorgenstadt. It's the Fed Gupel. That's where a horse goes around, and they had a little model there, which is nice. We didn't go to that. We wanted to find the mine. Next slide. Go into the museum here. Went into the museum, and there's an exhibit. Next slide. There's the exhibit here. Okay, in the year 1789, the Berlin person, Martin Heinrich Klaproth, discovered, okay, in the minerals of this particular mine, uranium. Okay. And I'm always reminded by, remember what Kennedy said, Ich bin ein Berliner? Yeah. Well, they're using the right, grammar here. Next slide. So here's what it looked like according to the picture 300 years ago. So let's go investigate. It's right on the Czech border. Right on the Czech border. Next slide. Looks like this. We'll go down here, and a nice little man helped us here because where we were a minute ago was about 2 kilometers over. And so we came down here, and there he was. He walked all the way down. He knew a shortcut. And next slide, he said, here it is. There's the mine here, and he told us all the things we needed to know. And next slide, here it is, all blocked up. It was active by the Russians. Really mined heavily out of this. Now it's blocked up, can't go inside. This is what it looks like. This is a mine out of which uranium was discovered, and so we discovered. So we have found it. And over to the side, we see a sign like this. Jenny, and you can read through here, very interesting, and shows all the interesting data and information about this. This is the Huthaus. That's what they call the main area. We find that very frequently in the German literature. So we read this, and if we can't translate anything, we photograph it and take it home and have somebody there translate it for us. Okay, sighting. We love this. Oh, we just love this. Just finding all these sites. Next slide. Well, so let's go over to Bohemia, the other side of the Erzgebirge. And when we do that, let's go down the hill. Here's Jakimov, which then was called Sankt Joachim, or Sankt Joachimsthal, the valley of St. Joachim. And this is the source of pitchblende for the Curies radium. Next slide. Here's a typical street, going down the hill again. Next slide, over to the side, we see things like that. Oh! Old dates, just beautiful, just marble. And we find the old mint there was 500 years old as well, still existing. That's where the museum is. Next slide. And here's the Sankt Joachim. And Joseph, we have to thank for this information too for getting us here. Thank you, Joseph. He isn't here, is he? Thank you. Next slide. Here's a coin we bought, 1561. This is one of the Thaler. Of course, you know this is the etymological source of the word dollar for us. This is King Ferdinand, who was emperor of the Holy Roman Empire. It was minted to him. Next slide. Pure silver. We had it analyzed. Pure silver. Here's the St. Joachim Church. Let's go walk up and take a look at it. So let's walk up here. Okay. Hey, there's something up here. What's this? All right. This is the church. Let's go up here and see what it is. Up here. Oh, this is Fornost Mine, which is the source of the Curies radium. Hey, it's still active. What are they doing with it? Well, let's find out. Well, this is the current source of the radioactive water, which they pump down to the radium palace, which we're going to see in just a moment. And next slide. Okay. Can anybody translate this for me? Well, you go through here and you see nickel and cobalt and arsenic and bismuth and uranium, and you can translate this radioactive water. Vodou is water, you know that because they get the word vodka from it, and seriously. So we know that word, okay. So they pump the water, the radioactive water, down to the radium palace. Next slide. Okay, let's do that. So here's what it looks like. Oh, just elegant, elegant. Let's go inside. All right, going up the walkway here. Let's go inside. Okay. Oh, beautiful in here. Interesting. Nobody spoke English. Few people spoke German, and so we had to talk in German, which is all right because German was their second language. German is my second language, and it's very easy to communicate. If your second language is your second language, because your vocabulary is about the same, you know, limited words, it really works. Next slide. And we go inside here, and they're all, what they do is they bathe in the radioactive waters, all the radon bubbling up, and if you die of cancer, I suppose it's okay. Hey, there's a picture. Hey, there's a picture on the wall, Jenny. What is it? What is it? Oh, it's Madame Curie. Their hero, of course, their heroine, yeah. And naturally outside, you'll see here is a park devoted to Madame Curie. This is the Curie Park, and we photographed this, took it home, had somebody who spoke a Czech translate it for us. It says Curie Park, yes. Next slide. And here's the tourist bureau and the museum we told you about in the same city. And right outside here, this little sign here, hit it, Jenny. Oh, thank goodness. It's not only in Czech, but it's in German too, so we can tell when it's open. It gave us a lot of help there. When we went inside to the information bureau here, to the museum, next slide, we'll see displays, but most importantly on the wall we see these postcards. And let's go to the postcards. And we see this is the Radium Palace, and this is where the works were, the Uran-Gelb-Fabrik was, the uranium yellow fabrication. And now it's where the park was. Remember you saw Jenny just a second ago sitting there? Well, now the Nazis tore that down. And now it's a park, and that's where she was sitting there. And up the hill, up here, is where the museum was we saw before. We came back down here. There's a Radium Palace, and this is before, obviously before World War II. Joseph, thank you for helping us with all this. Next slide. There's the Radium Palace. There's the Uran-Gelb-Fabrik. It means uranium yellow fabrication, manufacturing. And the reason they call it the yellow uranium fabrication unit is because, next slide, well they have these huge vats. These are postcards which are on the wall where they're separating out the uranium and all the other radioactive materials. Next slide. Can you imagine the radioactivity they're exposed to? Next slide. And this is what they made from it. This is quite the fashion. This is quite the fashion in London, in England. They make the yellow crystal from this, and that's what they were doing. Next slide. Well, here's how we visualize they took the ore from Pitchblende from Czechoslovakia all the way to Paris. This is how we visualize it. This was in Tilkarode, wasn't it? This is in the Tilkarode region where we were enjoying German science, nature, with the German cheese, käse, wine, and sitting there taking it all in. And they delivered this ore to Paris. Next slide. How are we doing in time? Told you we're going to go fast. We're all right, aren't we? All right, let's see Paris. All right, most of you or some of you have been to Paris. Yeah. Here's this. You really get an eye full if you look at this. Next slide. Okay. Fashions. This is in the Sorbonne region. Scenes such as this. Next slide. We stay in the Sorbonne. Chess. Now, Lutetia. We wondered why they call it Lutetia, and we found out it's because of the yellow clay, yellow dirt. And is there anybody who knows geology of Paris? I want to talk to you because I want to confirm that. I understand that the Romans call it Lutetia because it wasn't paved, because it was one of these uncivilized cities. And they had clay streets in some of the regions. In fact, we saw one time where they were digging and saw this yellow clay in there. We'd like to confirm that. Anybody knows any geology about Paris? Next slide. Here we are in the Sorbonne. This is some of our colleagues, professors who just happened to be at the same time. Jenny always takes the pictures. She punches buttons. Wonderful computer expert. And she's the one fixing the helping to fix the problems when I was in there eating. Yeah. Next slide. A minute ago. Here, now, just north of Luxembourg, it's funny what you bump into. We wander everywhere. Just walk, 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 walk. What is this thing? Well, we found out. Let's get closer. It is one of the original meter sticks, which they put so that a farmer could come out from the country, measure this, and take it home for the standard unit. And apparently it's the only one left in Paris, we understand, at this particular time. Next slide. All right, let's talk about Paris. It's a wonderful town to get into because a lot of the buildings still exist. This is 1630. There's only a couple of bridges here. To acquaint you, Notre Dame is right here. The Bastille is right here. And the Louvre will be built right here. And the Sorbonne is over here. Okay, next slide. Now, Turgot's Plan de Paris. He built 1739 this map of Paris upon the instructions of Louis XIV, I believe, so that they could better plan the city and in exquisite detail. Let me show you the detail. Jenny, let's take this section for example. This is Notre Dame right here, remember? This is this. All right, look at that. Here's Notre Dame again, okay. There's Notre Dame, we're going to be talking about that. Next slide. Then the Sorbonne, we're going to be talking about that. Hit it. And then up here, we're going to be talking about the Jardin du Roi. Up here, they call it the Jardin des Plantes. Right now, the Garden of the Plants. Hit it, Jenny. So you get a little arrow there, okay. Now, let me give you some more detail. Hit it, Jenny. Notre Dame, for example. Here you've been here. We found out how to get in here. We got behind, what was it, Japanese tourist group, and we just wandered in behind them. We got in free. Lightning did not strike. Let's hit it, Jenny. And here is, this is the Turgot's map again. More detail. You see where, there it's up here, right, up here. Here's Notre Dame. Let's get closer. Look at the detail. Oh, isn't it amazing? The whole city's like this. Look, you can read now the streets here, and it's fun going to the entire city of Paris and finding out what's there, which is there now, and streets have changed. It's always the case, but it takes a lot of detective work. We can't find it. Let's get closer. Oh, here, okay, let's find the detail. Looky here. Look at the amazing detail. Let's get closer. Let's get closer. Why, it's Quasimodo. Look. Yeah. Next slide. And down below here, next slide. We get closer. Yep, there's Esmeralda. Yep, she's down there. Next slide. Okay. Let's go to the Sorbonne. Now we stay in the Sorbonne. Jenny hit it. This region right here, where so much has happened. Next slide. And what we're going to be doing here in the Sorbonne is that you notice this cupola right here. And what we're going to be doing is we're going to be looking up here, and then we're going to go look up here. Look up here. Let's do that now. Let's sneak in. We're sneaking through these doors right here, and we look through here, and we see this cupola here we were talking about before. There's Louis Pasteur's statue on the side. You can't go into the Sorbonne now. They're much more restrictive than they used to be. We tried to sneak in, couldn't do it. Don't have the cards. Just back out again, Jenny. Next slide. And let's look up this way now. See, we're looking up this way. See, looking up this tower here. Let's look up this way. Let's do that. Next slide. And this is where we're having our drinks before. You get the idea. See, there's same region here. Our hotel is just on the other side here. Pretty cheap. 70 euros. That's pretty cheap for Paris. Next slide. All right, let's go to the Jardin du Roi, the Jardin des Plantes. Jenny, let's hone in right here. See that little region there? Let's hit it. See, Jenny, that's where they have a little labyrinth you can still go on. Let's get a little bit closer. We just found out, incidentally, that right here in one of these buildings is where Lavoisier was trained in his chemistry. Well, Lavoisier, heard of Lavoisier, who was the father of modern chemistry, and it took 5 years to find that out, but we did. He was right. The buildings are gone now, of course. Next slide. Back then, there was a famous place, touristy place. I mean, the French, it was fashionable to go up into the museums and to visit, because what was happening there is Paris was the center of the world, and science, and culture. Next slide. We had the Jardin de Pla, scenes such as this. This is the amphitheater we're going to see again in a moment. Next slide. We have here Buffon, who was talking about evolution way before Darwin did. Next slide. Here is Lamarck, who came up with the term vertebrates and invertebrates, all from Paris, from this region. Next slide. Inside they would have comparative anatomy and also chemistry lectures. This is where Lavoisier learned his chemistry. Next slide. Here's what it looked like back then, and they're restoring it now. They're restoring it so that now what you see in the next slide, this is what it looks like now. See, right here? Doing a real good job. Now, you know Jenny and me. We are inquisitive, and we gotta wander around. What's back here? Let's go find out, Jenny. There's a plaque. Oh, plaque. Gotta read the plaque. What does it say? And it says, in this laboratory, Henri Becquerel discovered radioactivity. And he did. And so that got us going. We wonder if they're going to tear down the building. No, they're going to restore all this area here, which is going to be wonderful. Next slide. And so this leads to scenes like this. This is the Madame Curie movie, which my class is viewing this very week while I'm gone. They have to view the entire Madame Curie movie, and then they have to write an essay on it, and they love it. It's a wonderful movie. Because it's romantic, it's scientifically correct. It talks about the hopes, fears, aspirations, successes, despondencies, etc. It makes science into a human experience, which I just love. Next slide. Here is Henri Becquerel. It actually looks like Becquerel. It actually looks like Pierre Curie. That's Walter Pidgeon, really. It actually looks like Madame Curie, Greer Garson, right? And so she's handing the pitch blend to, and next slide, I wonder what's in it, she's saying. And that turns the students on. And so she then goes in, and I give a demonstration in my chemistry classes at this point. I have a Geiger counter, and I show, here's uranium, here the radioactivity, see the radioactive level, now we put it on the pitch bend. There's something else in there. What's in there? And she went after it, and she found it. Next slide. Here they are. Boy, this is from the movie. Boy, just like the postcards, right? She got cancer too, you know. Next slide. So let's walk through Paris and let's find this area where she might be. Next slide. Okay, patchouli, perfume. Oh, this is the street, Pierre and Madame Marie Curie. So we walk down the street. And here's the museum right here. We go inside. Now I have to tell you a story. It's wonderful how Providence acts. Whenever something bad happens to you, it means that there's a reason for it. The very first time we went to Paris, we walked up and we're ready to go, and tout le monde en grève. The whole world was on strike. The metros are on strike. The buses are on strike. The Louvre is on strike. And so what to do? Well, the proprietor of the hotel said, well, you have to go with the foots. So we went with the foots. And we walked what happened? Did I do something? My voice changed. All I did was this. Hit with the foots. You hit with the foots. That's what I did. So I went with the foots and lost my voice. No. So we walked 8 kilometers. And they felt so sorry for us. Look what happened. Next slide. Special tour. There was nobody else there. Come in. Special. Here's the equipment. Most people don't realize that Pierre Curie and Madame Curie were necessary for one another. Team, just like Jenny and me. I mean, he built the equipment whereby she could measure the radioactivity. Next slide. Inside, Francie was discovered here by Perret. Next slide. And then her notes are still radioactive. I checked them with a Geiger counter. Next slide. This. And she says, oh, Madame, you must hold this mark of Madame Curie. Nobody else. And I'm sure she didn't, because they felt so sorry for us. So here's Jenny holding up this mock, and this we got a lot of mileage out of this picture, as you can well imagine. She was so diminutive. She only had 2 of them, only 2 like this, and it's undoubtedly radioactive. Still is. Yeah. That's why Jenny's so hot. Next slide. Let's get off this. Next slide. Okay. Now, actually, the radium and polonium was discovered where he worked, which was at the original ESPCI. This is the Municipal School of Industrial Chemistry and Physics. Next slide. And here's a plaque again. Ici c'est trouvé. Here was the laboratory in which they discovered the radium. Next slide. Well, here's how you discover it. Oh, it's so hard to get in some of these places. You have to know somebody who knows somebody who knows somebody who can get you in. That's why it takes 6 years to do this. So finally, here I am standing wishing, but we found somebody, took pity on us, and went right through this guard gate right here. We went in this courtyard. Let's go in the courtyard, Jenny. And here it is. Here, this area blocked out here is where the shed where they discovered it was. They tore it down because they park motorcycles there. And next slide. Here is the fellow here is Michel Lagus, and he's explaining to me very scientifically. And beautiful man. And there's got some Nobel laureates there. Some very excellent science going on at this particular institution. And here's some plaques and posters over here. This is where the laboratory was, where they actually did their work. What did it look like? Next slide. Look like, here's the shed, picture of it. Now in the movie, it looks exactly like this. They just, to the letter of the movie. Next slide. Here they are, working. Next slide. And we went to the museum. Michel Lagus, that person I just showed you, said, look at the Frenchman. Look at his eyes, so dreamy, so philosophical, so French-like. Look at the eyes of Madame, so hard and just like an American. But we were on good terms, and just jokingly. She was Polish, of course. Next slide. And the area here of the Académie de Sciences, where she actually gave a lot of her talks. Now, speaking of this, we're almost done now. It's time to wind it up anyway. Well, we got a little bit more. Next slide. And the same in Paris, I threw this in this afternoon because Vauquelin, who discovered beryllium and chromium, this statue is in the Faculté de Pharmacie of Vauquelin. He's holding this little, see this little vial here of chromium, de chrome, which is chromium. And next slide. This is where the third École des Mines on Boule-Mich, they call it. Boule-Mich is Boulevard Saint-Michel. Boule-Mich is, but he didn't discover it there. He discovered it in the second site. It took us 5 years to figure out where the second site was. We found it. Next slide. What happened there is that did notice that beryl and emerald had identical crystal shapes. I knew these slides would come in handy someday. Next slide. And sure enough, beryl and emerald had the same shapes. He said, maybe they have the same composition. Go after it, Vauquelin. So Vauquelin went after it, and he, of course, discovered beryllium. And here's a sample of element beryllium. This is a beryllium rotor, because extremely light, just like plastic, which goes into some of the rotors in some of the space vehicles. Next slide. And remember Turgot's map? We are confident. It took us years to find this out. They did their work right up here in the second École des Mines, which is taken from the Noailles family during the Reign of Terror around 1794. Jenny, let's hone in on this. We'll hit it again. And this is where they did their work. And it was once the home of Duke Richelieu, who invented mayonnaise. Huh. True enough. See, what happened is the rich family had it, the Reign of Terror, they took it away, and they built the École des Mines, then they restored it back to it again. All this history is going on. It's very difficult to decipher this. There is no picture of this place, and we are confident this is where it was. The only picture there is. Next slide. This is what sits on there now, the Department de Défense, in Paris. Next slide. I'm going to jump to Palermo, Sicily, where Ceres was discovered, because there, somebody was asking me about artificial elements. Next slide. This is where, next slide, technetium was discovered in this building right here in Palermo, Sicily. Next slide. And here is the hallway where the work was done by Segre. Next slide. Here is the person showing us the original equipment of him. This is all in Palermo. Next slide. And so let's leave Sicily. And this is a very good boat, because 10 minutes later, Berkeley is over here, some of you know. So if we go over to Berkeley, doesn't Jenny take good pictures? Oh man. We climbed a mountain hill to get up on this. Next slide. In Berkeley, on the university campus, next slide. We're just about done. Here's the Crocker Hall, which is the site of the original 60-inch cyclotron, which bombarded the molybdenum, which was sent to Segré to analyze to find the technetium. And if you go up on the hill up here, next slide, you find the Lawrence Museum, next slide, where they actually show the original cyclotron, which were up in Crocker Hall. Next slide. Now, Guinness World Records. When we were there in London talking to the people about entries they were going to put in there, they asked us, is it really true that, next slide, just hit it, that Albert Ghiorso discovered more elements than any other person? It's true. Albert Ghiorso. Has anybody heard of Albert Ghiorso? It's not a common name to know, but he was instrumental in discovering more elements than any other person. Next slide. And we were honored to visit with him. Here he is in his periodic table right here. This guy never got a PhD, and he discovered more elements than any other person. And he's just a wonderful, modest, beautiful person. And it's the same. Even to this day, he's still doing research, you know, and doing some scintillation studies. Just absolutely wonderful man. Next slide. Okay, wrapping it up. About 5 more slides, I think. The largest periodic table, now that we talked about almost right here, this is St. Petersburg. Now we're lucky again because when we went to the Leningrad Museum, which I'm not even going to show you here, they didn't tell us that after Mendeleev was fired, essentially, from that university, he went to the Meteorological Institute. And here is the only statue of him that we know of right here. And here's the periodic table they put on the wall. Next slide. Looks like this, kind of funny. But there it is. This is Mendeleev, and they put this up here in the 30s, we found out. Biggest element to the periodic table, permanent periodic table, we think. We're working on that. I'm going to tell the people in London, so maybe put in Guinness World Book of Records. And next slide. And she said, do you know about the Mendeleev vodka? No. Mendeleev is more famous in St. Petersburg, not for the periodic table, but for the vodka, because he put the vodka business on profit. And so he said, I'll get you one. So you get this bottle of Mendeleev vodka. See, I told you it was like water. See, Vodou, vodka, same thing. Next slide. And so, all right, we have to take pictures of it because we went on the train. It's ethanol plus water. It's what it is. Yep. Vodka. And there's something interesting right here, Jenny. What is that? Wow. You know, 104, they have the old Russian Khachatury as opposed to Rutherfordium, which 104 actually is, because they were naming according to the names that they wanted to use. Now, we've got this bottle home, unsmashed and unopened. So we have no idea what it tastes like, but it's sitting on our element collection along with all the rest at this particular time. All right, next slide. Here he is, the father of it all. And in the first week of classes for my chemistry classes, I have a history of the periodic table where I lead them up to how the periodic table was invented, and they learn a lot of chemistry during that time, and they appreciate it. Because my mother-in-law once said, when I asked her, what do you remember from chemistry? She said, I remember only 2 things. First of all, damn hard. And the second one was, there was this thing on the wall. Ma, b, wa, ni, wa. I never did figure out what that thing was. So what's the periodic table? So we teach them what the periodic table is. Next slide. Okay. 3 more slides, I think. Surprises. Surprises. Any of you ever heard of Oliver Sacks? Oliver Sacks wrote some masterpieces. And while we were walking through Freiburg, not Freiberg, which is where we were before, but Freiburg, this is over on the in the Black Forest. There's Jenny over there, and this showcase, next slide, we see that there's happy birthday, in English, happy birthday Oliver Sacks, because, hit it, Jenny. He was the man who wrote, the man who mistook a wife for a hat and Awakenings in those stories. Well, he also wrote a book called Uncle Tungsten. Uncle Tungsten, in which you talk about his boyhood experiences. with his uncle who had a light bulb factory and learned all about the elements at that particular time. And he wanted to come down and see us. Next slide. So here he is. This is what our living room or kitchen, our living room looks like. Because we couldn't bring it with us. We have a sample of every element from 1 to 92. And it's the only one in the world. We know that. We know other places used to have it. Like the Field Museum in Chicago years ago. They've done away with it. I don't know what they've done with it. They don't display it anymore. And it took us years and years to collect this. And he was like a little boy. He said, "Oh, let's play with the bismuth. You know, it's diamagnetic. Just hang it by a string, put a magnet so it would twirl the wrong way." And he said, "Oh, let's do the gallium. Let's melt the gallium in a cup of tea." And he played with that. And he spent several hours in our room. And here's our collection. It extends, actually, it's 1, 2, 3, 4, 5, 6 cases here. And winding this up, thanks to people like you, we were able to procure a sample of a mineral from the original source for every element, from the original place, with one exception. It's fluorite from Garsberg, Sweden, and we can't find a sample of that. But if we can find that, then we will be complete. It's time, isn't it? Steve, is it time? It's about time. So that is our story. Just a hint. I hope you had a good time with us, because isn't that fun? And the best thing about it all is it's all deductible. So when I give my talk to the chemistry people, I say, how to visit Paris and claim a tax deduction. Okay. Yes?
Where is your specimen of columbite from?
It's from Connecticut.